Hi, Assalamualaikum. My name is Muhammad Nabil Farhan bin Muhammad Nasir, and my matrix number is CF190230. And our title project is Roof Truss for Grandstand at Baseball Stadium. This is an example of baseball stadium and example of roof truss at the grandstand. We choose baseball stadium as our project as it inspired from the roof truss design that come in cantilever design. As usual, we will always see the normal roof truss that come in triangle shape. As for grandstand roof truss, it come with this size and 4 column, and this size for top and bottom yard, and this size for bracing member. And this is design concept. The process of design is with STEAM material begin with a study of the design of the machine structurally, environmentally, or effectively, and usefulness. Following that, the design will proceed with manual calculation and be compared to step pro software. For this project, we are required to provide a comprehensive design and propose stadium steel truss. We are using an existing baseball stadium design layout for our project. The layout that we refer is from CSL Engineering Spain. This stadium side length is 99 meter. It also comes with 115 and 59 meter distance from home plate to center field. This stadium includes grandstand for seater. And for this roof truss, the design we choose is cantilever truss, as it is reliable for grandstand itself. And for erection methodology, the invitation discloses a large span cantilever truss construction support process that includes the step is below. This is for the erecting temporary support device at a cantilever truss node, as well as aligning with the upper planes of the temporary support device. Putting together and positioning a lower cut member, then putting together a wet member component, and finally putting together an upper cut member. Modifying the structural position of the cantilever truss built into step. Welding, fixing the lower top member, wet member component, and upper cut member. Vertically lifting the welding fixed cantilever truss to the required position using a vertical lifting device. And for attachment engineering, a cantilever truss is supported on one side alone, which is designed to be much heavier than unsupported side. So it does not set even weight is added to the unsupported side. A truss is made up cord top and bottom, and the web with two top cord components in a pitch truss. A truss web components are always in opposition to one another, so if one is in tension and the other one is in compression. The top cord is a constant tension, while the bottom cord is constant compression. The truss triangle can be arranged in a variety of ways, each with its own set of benefits and drawbacks, but they are work on the same specific principle. Thank you.
Hi, my name is Muhammad Shazan bin Muhammad Ramli. My matrix number is CF190222. Okay, today I want to present design overview. So let's we go to the first slide, architectural layout. So this is our architectural layout for stadium baseball plan. And then this is a roof plan of grandstand. We can see the plan. And then this is a structure layout. Alright, we have a roof truss, front view, and a side view. So okay, this is a frame geometry. Alright, we are given a job to propose a steel truss of a stadium. The typical part plan and the cross section for this purpose design building were given as a reference. The proposal should include a design for the internal columns, truss member, and the number of different connection type to complete the proposal. Okay, figure show the illustrate of the proposed steel frame geometry structure design for the whole structure, and figure show 3D rendered view based on the Step Pro software. Okay, we can see the two figure. Alright, and then this is connection types. We have two connection type. First is welded connection, and second one is the bolted connection. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Nazira binti Shamsuddin. I will talk about compression and tension for main truss and the comparison between manual and software calculation. Compression and tension for main truss. The top chord member, all nature are tension. For bottom chord member, all nature is compression. For vertical member, for 114 and 113, the nature is tension, and for 112, 115, 116, 117, and 118, the nature is compression. For diagonal member 121, 124, 126, the nature is tension. For diagonal member 120, 122, and 123, and 125, the nature is compression. Since there are no horizontal load, then there are no horizontal reactive force. Comparison of design result for manual calculation and step pro software is for top chord and bottom chord, the design for lambda z is more than 1, which is not okay. And comparison of design result for step pro software, we can see that critical condition and the deflection is fast and safe to use.
Assalamualaikum. My name is Muhammad Farhanuddin bin Muhammad Fuzil. Today I will present design, tension and compression truss member of our project. Okay, these are the design for tension and compression we get from software analysis, which is Start Pro. Okay, for tension member 114, we get 0.384 as a vertical. After that, member 113, we get axial force 8.19 vertical, and then member 1 to 1 axial force we get is 97.31 diagonal, and then member 1 to 4 we get axial force 101.73 diagonal, and after that member 1 to 6 we get axial force 31.62 diagonal. After that result for the compression, member 116 we get axial force 19.70 vertical. Then member 117 axial force we get 13.57 vertical. After that, member 120 we get axial force 37.40 diagonal. Then member 122 axial force we get 136.31 diagonal, and then member 123 axial force we get 81.82 diagonal. After that, the design for tension and compression we get from manual calculation. Member 114 axial for tension, axial force we got 0.384, size 100 pKa 100 times 100 times 10, which is allowable. After that, member 113 axial force we get 8.19, size UKA 100 times 100 times 10, which is allowable. And after that, member 121 axial force we get 97.31, UKA 100 times 100 times 10, which is allowable. Member 124 axial force we get 101.73, size UKA 100 times 100 times 10, which is allowable. For member 126 axial force we get 31.62, size UKA 100 times 100 times 10, which is allowable. For the compression, member 116 axial force we get 19.70, size UKA 100 times 100 times 10, which is allowable. For member 117 axial force we get 13.57 UKA, size UKA 100 times 100 times 10, design is allowable. For member 120 we get axial force 37.40, size UKA 100 times 100 times 10, design is allowable. For member 122 axial force we get 136.31, size UKA 100 times 100 times 10, design is allowable. Lastly, for member 123 axial force we get 81.82, size UKA 100 times 100 times 10, this design is allowable. That's all from me. Thank you.
Hello, my name is Umar Rizwan bin Umar Aziz. Management number CF190216. So for the conclusion of this project, we have received a great deal of knowledge, including applying what we have learned in class to this project, and we have grasped and comprehended the concept of steel structure design. We are also aware of the benefit and drawback of the steel frame. Despite this, there are still safety precautions in place for the steel structure. Steel structures are noted for their ductility and ease assembly. In short, this design job was completed effectively, and the concept of design steel structure was truly grasped. Okay, for the recommendation, firstly, simple roof truss structure with at least 20-degree pitch are necessary in areas with severe driving rain. Wind suction can produce force larger than self-weight. For the bolt connection, we should use 16, 20, and 24 and 30 mm bolts. Not recommended 22 mm and 27 mm bolts. Then maximum spacing ensure that the plate section between both doesn't collapse in compression, while minimum spacing prevent local crushing from affecting surrounding bolts. Lastly, less than 60-degree angle are partially penetration but well. For angle larger than 120 degree, the system should be tested according to EN 19 NXD. That's all for me. Thank you.